Okay, we start our class now. Good afternoon, Form 5 student. Okay, all the Form 5 student. So see you again for first lesson of this week. Form 5. I hope everyone feel energetic. Yeah, good afternoon. Good afternoon, Chong Han. Everyone feel energetic to go back to school tomorrow. Okay, don't feel sad lah. Don't feel sad to go back to school. After all, this is your last year. Most probably, this is your last year in your school already, Form 5. Okay, so left about 2-3 months only you stay in the school. So go back school lah. Okay, don't feel sad to go back school. So we feel very happy to go back school tomorrow. Form 5. And another things I'm sure some of you already know, right? Your school year, this year you will study until very late. Your year-end holiday very late, Year-end holidays are only 11 or 13 days only. Previously, every year's year-end we have 42, 43 days. But this year they cut short to only, just now I saw it's about only 11 or 13 days only. So especially the Form 5 student, kasihan you all. Form 5 student, you're going to study until 19th of December. 19th of December only start holiday, Then you say bye-bye to the school, 19th December, right? It's holiday already, bye-bye to the school. But your SPM is next year, February. So meaning that after 19th December, you all have to study, very hard study yourself at home, until next year, February, only come back to school for the SPM exam. Kasihan you all. Drag so long. Okay, your school year your school day study until 19th of December, and then your SPM next February only start. After, I think most probably it's after your Chinese New Year. Okay, after Chinese New Year only start your SPM exam. So actually, when we look at another aspect, this is something good for you all. You have a longer time to do preparation, longer time to study But if you take it negatively, you will think that you will torture for a longer time. So I hope you don't take it negatively Take it positive. Take it positive means you have longer time to prepare, so you can do better in your SPM. Take it positive Okay. Yeah. Okay. So let's go back where we stopped last week. Last week we answered the last questions on transmission of electricity. The last questions you got a little bit, right? Okay, let's go to the last part first. Okay. Yeah, I share the paper with you all. Last question. I think it's somewhere here. We stop here, right? This part. The calculation we stop here, right? Okay, this one we have done already. Okay, this one finished. Okay, so transformer PQR, so we have solved everything. So next part of the question, okay, next part is they ask you to find. You see the question. This one we discussed already, answer calculation, right? Okay, next one is the types of core you will use. What types of core? So we already know, right? So we take laminated soft iron core. This one, this is the best laminated soft iron core we choose but we have to keep the reason, Okay, and the last part of the question is material used for the transmission wire. Okay, for the wire, we chose copper because this one is in the lab. You see, this is a lab, not in the real one, not the real transmission. If the real one here, we use aluminum, but this one is inside the lab, so the best we choose copper So we choose copper, and here we choose laminated. And then we keep our reason So the answer is like this. Okay, we choose laminated soft iron core. Okay, the reason is Laminated can reduce eddy current. When you choose laminated, one layer followed by one layer, right? It can cut down the eddy current because eddy current cannot flow through from one layer to the next layer, so cannot. So it cut down the eddy current. You have to keep two reasons, because laminated got one function, soft iron got another function. Soft iron is to reduce high hysteresis loss. So both you have to mention, Laminated is to reduce the eddy current. Soft iron is to reduce the high hysteresis loss. Okay? Yeah. And the last part of the questions we choose copper wire. The only reason we choose copper wire is because low resistance can reduce the power loss. Okay? Because copper wire resistance is low, so it can reduce the power loss. Okay? That is the whole answer for this question now. Okay? All right? You done on this paper or not, everyone? Understand the whole chapter. Any question here? Liao Xing Xiang, any question? Liao, your mic, you didn't off your mic. Now you off already. Okay, thank you. Anyone, any question? Okay, no, no question here, everyone. Angel Tam, anything to ask or not here, Angel?
No, sir.
No question, okay. Wei Xiang, you got anything to ask? Wei Xiang?
No, sir.
No, sir. Yuan En, anything to ask? Tan Yuan En?
No, sir.
No, sir. Then I ask you all, laminated is what? I don't want to scare you all, okay? Okay, now mind. So we have finished this chapter 3. Electromagnetism, we have finished already, Okay, so for tonight, I want to start the last chapter. I skip the electronic chapter. Later on only we do. Because electronic is very, very difficult, very tough, very long. The one when close to your trial exam only we go through the chapter. Okay, now I pick the last chapter to start first. Okay, last chapter, the one is more on theory. The one I think not so difficult. Okay, so now let's see. Okay, can see the paper or not, y'all? Can see the paper? Sorry. Angel, can see or not?
Yes, sir.
Can you tell me what you see?
See the title,
Title is what?
Radioactivity.
Yes, correct. Okay. Thank you. All right. This chapter 5. Chapter 5 is you study everything related to radioactive. Okay, radioactive. Okay, but we don't call radioactive here. No, the name is called radioactivity. Okay, radioactive. I'm sure you know what is that, right? Radioactive. Radioactive is something very powerful, carry a lot of energy, and very dangerous. Okay, it's one of the most powerful weapon in the world. So we can call radioactive. Most powerful weapon. You can kill a lot of people when radioactive. Okay. Nowadays, you notice or not, more and more people suffer from cancer. See, cancer one of the main reasons to cause cancer is radioactive. Radioactive, actually surrounding us actually now is already full of radiation. We never realize only, We never realize actually surrounding us they are full of all types of radiation, alpha, beta, gamma, so many types. They are surrounding us already now. We don't know because this radiation alpha, beta, gamma, right, has no smell, no color, cannot be seen one. Okay, so that's why I call them very dangerous. Cannot be seen, no smell, and then some more when they travel, no sound one, you cannot see. Okay, Unless you are using a device like a pen, right? A pen, a special device like a pen, you always put inside your pocket. When the pen got sound means your surrounding your body got radiation, and then you can avoid it. Okay, so there are a lot of people do that already, like carry a device to detect the radiation. Okay, okay. Now we look at the title now. Is understanding the nucleus of an atom. Okay, we see now. Our main title is radioactivity, radioactive. But why we go and study the nucleus? Why study nucleus for what? Huh? Okay, let me tell you. These radioactive things are actually is come from the nucleus one. Come from the nucleus of the atom. When the nucleus of the atoms are divided, break, right? You say, when you're able to break the nucleus of the atom, then something very powerful can come out, okay? So this energy comes from the breaking of the nucleus. When you break the nucleus, then this type of energy come out. Designed to study radioactive, right? You have to start with the nucleus. Okay, start with the nucleus first. Okay, come, let's look at this. Okay, so it's here. All right. So first we start studying this nucleus. So we see the atomic model. Okay, atomic model. First one is Dalton's model. Okay, all these are the history of atom, history of nucleus. We need to know a little bit, okay? The history, how the scientists go year by year to get more and more understand about the nucleus, more understand about the atom. Okay, we study Dalton's model. Okay, what this model say? Something very like this. He said, matter make up of very small particle called atoms, meaning that atoms was first introduced by Dalton. This scientist was the first scientist who introduced to the world that all the objects in the world, right, make from small things. So this small thing is called atoms. So he said that. So until now, it's still correct now. Atoms. Atom can neither created or destroyed. Until now, still is correct. This is what he said. Atom cannot be created, cannot be destroyed. Okay, we say they are conservation, principle of conservation. So cannot be destroyed when they are always there. Okay. All atoms of the same elements are identical. When they are the same elements, mean they are same one. The atoms are identical. For example, like carbon, carbon dioxide, carbon monoxide, all these they are identical one, same elements. Okay, and different elements have different types of atom. Of course, when the elements are different, for example, carbon and nitrogen, they are different elements, right? Of course, the atom also different. So everything said by Dalton until now is still correct. All correct, no. Everything until now is still correct. Okay, the next model is Thomson's. This one, Thomson's model. Remember the name, You don't know the detail, at least you must know the name, Thomson's model. Plum budding model. Okay, what he say actually is not correct already now. You see, what he say atom is a solid sphere. We say it's a solid sphere, Positive charge with the electron distributed uniform over. He said, here is positive charge, that the electron distributed over uniform over it. This is not correct. Because the correct one should be the positive charge is not around here, no. It's at the center, the nucleus there, only a small part positive nucleus. Whereas the electrons are surrounding outside. So this is totally wrong already, So you just remember Thomson's model, the name you know already, The detail actually is wrong, not correct. Okay. Third, this is the most important, Rutherford model. Okay, Rutherford. Okay, in fact, the models of atom we study now is actually Rutherford model. Most of it is under Rutherford. Okay, Rutherford and his another two student help him a lot. Okay, Rutherford. You see what Rutherford say now? Atoms that a positive charge core or nucleus. You see, he was the first one say atoms are got one core center here. So this center we call it nucleus. So first introduced a nucleus. He was the one, Rutherford. So he say the atom got one small center. This center is called nucleus. Then he say lah, okay. Then he say it's positive charge one. He say here is positive. So it's until now is correct. The center nucleus memang is positive. Okay. Yeah. So this is what he say lah. Then somehow he say contains most of the mass. He said the whole atoms this part the nucleus containing most of the mass. So the rest are all empty. He said empty one. Only here got mass. So it's correct lah. Contain most of the mass and which surrounded by orbiting electron. The electrons are orbiting, turning, orbiting here lah. Is correct. Okay. In fact, what we learn now is like this, right? Center nucleus, then the electrons orbiting around, turning around, right? So center is positive, so it's correct. Okay. But Rutherford only introduced, say, like this. No evidence, he did not prove it when he passed away. He never proves it. What he said was correct using experiment, Okay, then what happened was, after this Rutherford passed away, right? So his two young students, the two students of this Rutherford continues his work to further carry out experiment, very famous experiment, to prove what his professor said correct. Okay, you see what he said now, the two students. The two students under Rutherford was, two of them Geiger and Marston, these two are his students now. Okay, so these two students carry out one very important experiment. Geiger, Marston planned and carry out an experiment proposed by Sir Ernest Rutherford. He passed away already. He proposed only, but he never do it. Then he passed away. So the student carry on now. Okay, and found evidence for Rutherford model. And then these two students carry out the experiment and prove with evidence the theory of Rutherford is correct. So proof. Okay, what these two men did was like this. You see this diagram first. Okay, look at here. This experiment is very important now. It come out with the SPM many times on, Okay. Okay, these two young men Geiger and Marston, right? So what they did now, they put this metal foil. Metal foil means they use a gold leaf, gold paper. The paper made from gold. One piece of gold paper put here. Then here they use a gun, a gun. This gun can produce alpha particles. Okay, alpha particle, not here, sorry, alpha particle is here. Okay, these alpha particles is a positive one, like proton. So like electron, you can shoot over, go through the gold paper. Okay, see this diagram, I think clearer. So what happened was this, these are the atoms of the gold paper. One piece of gold paper. So here got many atoms, you see or not? Then he use a gun to shoot these alpha particles. Okay, alpha particle actually are helium. So remember alpha particles actually is helium 24. Helium you have hydrogen, helium, all this you know one, isn't it? Helium means is positive charge one. Alpha particles is helium is positive charge. So he used this one like a bullet use a gun to shoot it over you like bullet. These bullets actually are all proton, positive charge, alpha particles producing positive charge. So all these positive charge, okay, most of these when they fire, shoot, but most of it go through in a straight line. You see, most alpha particle pass through undeviated, means so many times he fired, right? most of these go through in a straight line. Then he made conclusion, Why all the positive bullet he fire can move in a straight line? Because then he made conclusion, he say, got a lot empty space. A lot of empty space, that's why most of it go through in a straight line. So remember, when more alpha particle go through in straight lines, we make the conclusion the atoms actually are empty, a lot of empty space, many empty spaces. So the sign very easy to go through. So this is correct. So he proved already. Okay. Then he noticed when this alpha particle positive charge one go near to the atom, when go near get deflected, go near got deflected. Why got deflected? Because this one is positive, then here is also positive. So positive rebel. That's why this alpha particle get deflected. So he made conclusion. He said nucleus are positive charge because this alpha can be deflected so positive deflect okay. So a few alpha particles are deflected through large. No, this is small angle, not large angle. This one change to small angle, small angle. Like this is considered small angle, deflected so a little bit. Okay. The reason this deflected was because when go near, so alpha is positive go near to this nucleus positive, so rebel to say deflect. So he make the conclusion, he say nucleus are positive charge. So it's also correct. Okay, then another one he noticed when this alpha particle hit exactly on the nucleus, right? He got bounces back in big angle. You see, hit then bounces back. So this is another one further to prove that this nucleus is positive because a proton alpha particles, right, hit exactly on the nucleus positive get bounces back. So positive hit positive bounce back Small number are actually scattered backward. Why scattered backward? Because hit exactly on the nucleus. When go near nucleus, got deflected, small angle. When far from the nucleus, goes through direct. So he showed that, you see now. Oh, so many times he fire, right? He say 1, 2, 3, 4, 5, 6 times go through in a straight line. So meaning that a lot of empty spaces Only one deflected small angle go near to the nucleus. Only one bounces back because hit exactly on the nucleus. So it proves that the nucleus is positive Understand Understand this experiment or not? Angel Tam, understand?
Yes, sir.
Understand What's the name of the experiment? Angel? What is the name of this experiment Huh?
Don't know.
Use his teacher's name Rutherford's experiment. Okay, this just say this is Rutherford experiment Okay Now we look at the detail Okay, come look at the table. The table give you the explanation okay. Yeah. Okay, first one from the result here. Most of the alpha particle pass through straight line. Okay, straight through the foil. Okay, pass through straight the foil. You remember jot down alpha is helium-24 is positive charge one alpha. Okay, the conclusion he make is most of the space taken up by atom must be completely empty one. Very easy to go through, so all empty A very small nucleus placed at the center. Very good conclusion. This is a conclusion. Proof what his teacher say was correct. Okay, the second observation I say now, a few alpha particles were deflected through very small angle. Small angle, this one considered small angle. This I told you here change to small angle. Get deflected. Then the conclusion he says is what? The nucleus are positively charged. Okay. The alpha particles also positive charge are repelled by the nucleus because repulsion force is produced between the light electric charges, positive and positive light Okay, that is the conclusion now. Okay, and then the third one is this one now. Okay, bounce back one. A very small number of alpha particles were bounced back by the gold foil. Okay, gold foil means it's a piece of very thin piece of gold paper, so we call it gold foil. Like aluminum foil, the one used in cooking one, aluminum foil. The one made from aluminum, this one made from gold. Okay, so it's called gold foils. Okay, the reason is saying when alpha particle approach very close to the nucleus, very close or exactly on the nucleus, they were exerted by very large repulsion force, because repulsion force obey, this one you don't need to know yet lah. You just really need to know when hit exactly on the nucleus was positive and alpha also positive, so the repulsion force becomes so big now. So we push thing to go back, bounces back. So okay, understand this Rutherford model. This one very important. Oh, so many models you study here now. The most important is Rutherford. Okay, Rutherford model. As an introduction to your study of radioactivity, radioactive. Okay, okay. So far, understand. Tan Yon En, are you still there? No more there already. Xing Xiang, understand? Liao Xing Xiang,
Yes.
still there now. Okay, okay, good. Okay, next. Okay, we move on to next one. Bohr's model. This one, another two more here. Bohr's model, what he say? He say, atom has electron in stable orbit around the nucleus, like planet around the sun. Is it correct? Isn't correct or wrong? Electrons in stable orbit around the nucleus, surrounding the nucleus, so it's considered correct now. Okay, next, Chadwick's model. Chadwick's model was the first who introduced neutron. In fact, Rutherford one so famous, Rutherford also never mentioned, never introduced neutron. He only say got proton positive and got electron outside, but he never introduced neutron until this fellow come out, Chadwick. And he was the first scientist introduced the world. Beside proton, beside electron, there's another one, they call it neutron. Okay, this man now. The neutron as a neutral particle found in the nucleus. See, very important. What he says is very important. For now, he say inside the nucleus, not only the proton positive only. You also got something very neutral. One is called neutron. Neutron as a neutral particle found in the nucleus, along with proton. You see what he says is very good. Is correct until now. So remember this man, Chadwick. He was the first introduce neutron to the world. Okay, and for today's model, okay, now the model you study now lah. Now most of this you study now actually is Rutherford plus a little bit from Chadwick's one. The atom with a very small and very dense nucleus. You see atoms got one very small nucleus and very dense. Dense means very density very high, very heavy one. Dense nucleus surrounded by cloud of negative electron. Outside here got negative electron. This negative electron is orbiting here lah, keep turning here. In the nucleus, you see got proton, neutron inside. Then outside was electron circulating now. Okay, so this was what we learn now lah. The electron may be represented by wave of clouds around the nucleus. The nucleus is made up of proton, neutron, and core nucleons. Understand? When you combine neutrons and proton, you call it nucleon. Nucleon, okay? Remember this word, nucleon. Nucleon means it's combining proton plus neutron, so we call it nucleon, okay? Yeah. Now, protons, neutrons, electrons are the fundamental particles of atom. Now, the most important things in the atom was these three: proton, neutron, electron. Fundamental particles of an atom. Okay, the properties of this tray. Okay, this time we go through now. Why someone ask question now? Teacher, no sound already. No sound already. Angel, you hear? Can you hear the sound?
Yes, sir.
You can hear me.
Yeah.
Xin Xiang, you hear me or not? Yao Xin Xiang, can you hear me? I think like that. The one who say cannot hear me one, maybe you have to come in again now. Is something wrong with your line or what? Now my Jeff, you go out, then you come in again, Jeff. Okay? Jeff, you go out, come in again, then you can hear. You are using handphone, then you restart your handphone. Yes, you quick and rejoin. Yeah. All right. This part very simple huh? So yeah. Proton, neutrons, electrons are fundamental. Okay, now in the mind you look at all these charge, proton positive, you know one, electron negative, neutron neutral, no charge. Okay, very easy, Relative charge positive, proton is positive one, electron negative one, means same, no. This one is one, this one is one, but this one positive, this one negative lah. Whereas neutron, neutral, no charge. Values of the charge, okay, the values in coulomb. In chapter 2, you learn the unit for charge is coulomb. Then, okay, Jeff come in again. I hope you can hear me this time. Okay. Value of charge, you see, proton, now the charge is 1.6 times 10 power negative 19 coulomb. Very little charge on it. Power negative 19 coulomb, but it's positive. Electron, same value, but negative 1.6 10 to the power negative 19 coulomb. That means proton and negative and electron carry the same charge one, same. The only one positive, one negative. Whereas neutron, no charge one, zero. No charge at all. Okay, the mass, relative mass means compared to carbon. Proton, 1. The mass is 1 compared to carbon. Electron, 1 over 1840, meaning that 1 proton, the mass is how many times the mass of electron? Is 1,840 times. Very heavy, proton. 1,840 times heavier compared to 1 neutron electron. So you see the difference. Neutron mass same. Neutron and proton, their mass same one, Only electron very light, electron very small. Okay. The actual mass in kilogram. So this is a value in kilogram. 1.67 10 power negative 27. This one lighter. Power negative 31 kilogram. This one neutron same. Then the symbol, I think you know. Proton you put P 1. Electron negative 1 0. Negative so him negative 1 Okay. Neutron is 1 0. The symbol have to know. Proton is 1. Okay. Electron is negative 1 0. Neutron is 1 0. Okay. So these are the things you need to know about the three things: proton, electron, neutron. Okay. Okay, next. What is I think you have learned in your chemistry also okay, now, proton number Z and nuclear number A. Okay, when you give a name, give a symbol to an element, right? Normally you write X, the symbol X. You put Z. Z is proton number. Proton number. A is nuclear number. So you see here A is nuclear number. Z is atom number or proton number. Same one, atom number or proton number. And X is a symbol of the elements, copper, aluminium, zinc, so you put the symbol here. Okay, and you must know this. Z proton number is a number of proton, right? How many proton? Whereas the nuclear number A, nuclear number is the total of proton plus neutron. How many proton plus how many neutron? You add up, this is a number. This one is the number of proton. Here is the number of proton plus neutron. Okay. So you see the form, you see here now. Example, hydrogen 1, 1. Okay, hydrogen 1, 1 and proton number 1 means proton 1, you see. Okay. When proton is 1, automatically the electron is 1, same one, because neutral. One proton must have 1 electron, same one. And then neutron is 0 because 1 plus 0, you get 1. So the 0 neutron must be 0. Okay. Up here is proton plus neutron, 1 plus 0, you get 1. Okay. So 1 plus 0, you get 1. These are nuclear number. Then for carbon 12, proton number 6 got 6 proton. Neutron also 6. 6 plus 6, you get 12. Okay. Here is 6 plus 6, 6 proton plus 6 neutron, you get 12. Okay. Nuclear number is 12. And electron always same as a proton. When you have 6 positive proton, you must have 6 negative electron. Neutral. And the last one, chlorine 35. So 17 proton number, so you have proton 17, neutron, electron also 17, whereas the neutron is 18 because 17 must add 18 to get 35. So here must be 18 non-neutron. Okay, because 17 plus 18 you get 35. Okay, nuclear number is 35. I think this one you can understand one. Then Divish can understand. Divish, are you here?
Yes. Yes, sir. Yes, sir.
You must be dreaming now, correct not? I call you while you terkejut. Then Divish, tomorrow going back school, not Divish.
Huh?
Tomorrow going back school, not?
Yeah, I'm very sad.
I know you're very sad, you Divish. You don't want to go to school, no good, must go to school. Okay, come next, nucleus. Types of atom categorize its proton number and nucleus. Nucleus means is a smaller components of the nucleus. This one not important one. Okay, next. Isotope. This is more important. Isotope. Also, you learn in chemistry. What is isotope? Now in physics, this isotope become very important. You know why? Why isotope become very important? Because isotopes are the one who are radioactive. When you talk about isotope, isotope is not good one, because isotopes are all radioactive one. Okay, like hydrogen, you see here, you look at here. Hydrogen got 1, 1, got 1, 2, 1, 3. The normal hydrogen is 1, 1. This one is normal one. This one no dangerous. This one normal hydrogen is neutral one. But these two are the isotope. 1, 2, 1, 3 are isotope of hydrogen. These two are dangerous one, That's why you see here. Hydrogen 1, 1 is stable. This stable means not dangerous. But these two are 1, 2, 1, 3, they are isotope. So they are unstable. So they are radioisotope. Radioisotope means they are radioactive. They can produce weapon, can kill people one. This one no good. Okay. There are a lot of things here also got isotope one. Okay, never mind. Now we go see what is the meaning of isotope first. Okay, highlight here. One of two or more atoms of same element that have the same proton number but different nuclear number are called isotope. Same proton number you see here, all this 1, 1, 1. The proton number all same, correct not? Hydrogen say 1, this one 1, this one 1. The proton number all same, but nuclear number different. This is 1, this nuclear number is 2, this nuclear number is 3. So same proton number, but different nuclear number. This one become isotope. Okay, so remember now, same element that have the same proton number, but different nuclear numbers, so we call them isotopes. Okay? Okay, then same chemical properties are determined by the numbers of electrons. So these are chemically properties how the chemical reaction can happen, right? It depends on the number of electrons. That's why isotopes of the same element have similar chemical property. In terms of chemical reaction, they are the same one, hydrogen 1, 1, 1, 2, 1, 3, or same one. Chemically, they are the same chemical effect. But physically, the outlook, physically, they are different. Maybe this one is gas, maybe this one blue color, different one, this one different color, right? Chemically same, but physically they are different. That's why you say here, chemical properties are determined by the, so isotope have the same element, have similar chemical properties, okay? But remember, chemical properties same only, then physically they are different, okay? All right, so this one example, hydrogen 1, 1, hydrogen 1, 2, we call it deuterium, 2, 3, tritium, 1, 3, okay, tritium, okay, 1, 1, 1, 2, 1, 3, okay. So these deuterium and tritiums are isotope, and then they are unstable, and then when unstable means they are tends to release the radioactive. So we call them radioisotope. Okay, I wonder some of you may ask, why stable, this one unstable, what is the meaning? Okay, come, let me explain. I'm teaching chemistry now. Okay, hold on. Okay, stable means they are not active. Not active means they won't release radioactive. Because they are like dead already, Stable means they are like dead, not active anymore. So they wouldn't release any dangerous thing now. Okay. Then this one unstable. They are unstable, Unstable means they are very active, very active, Very active. Okay. In the process of very active, they want to become stable down, right? All the chemical things are like that one, At a certain time, they are very active. Once they are very active, right, they will want to achieve the stable life later on. Okay, now they are active. Later on, maybe few months after that, they become stable. Okay, this process is called decay. Decay process. Decay process. Now you see here, decay. Decay process. Okay, decay means it's a process of become stable. From unstable, very active, one to become stable. So the process of changing from unstable, one to change to become stable. So we call it decay process, or we call it actually another meaning easy for you to understand is called dying process. This is a process this thing going to die. Once it die already, dead already, right? So become stable. Okay? When they are alive, they are very dangerous. Produce radiation. So very active, active, active. So later on, they're old already, they will die. Okay, die. So become stable. Okay. In chemistry, we don't say die one, or we say become stable. Stable means are not active already. Okay, not active, no life already. Okay. Yeah. Okay, now radioisotope which unstable nucleus tends to decay. Okay, decay later on in lesson 2, you will study decay. Decay is a dying process. The very active atom die, then finally become stable. So this process is called decay. Decay process. During decay process, it will release radioactive things. Okay. Gamma lah. Okay. So far I can understand. Okay, let me look at your face first. What this fella want to sleep already one. If you all listen to me talk, and then you all never talk, and then you'll sleep, or you all. You don't understand? You don't
Understand.
understand? Jong Han understand?
Understand.
Yeah. These are Jiu Kai Ji, understand?
Yes, sir.
Yes, sir. Okay. Yes, sir. What you understand, Jiu Kai Ji? Tell me. What you understand? What you study, Jiu Kai Ji? What you understand? Tell me.
Rutherford model.
Oh, Rutherford model. What is importance of Rutherford model?
Got a core, a positive core.
Oh, positive core. Then?
And then got the orbiting electrons.
Okay, correct. Okay. Kirtana, what about you? Kirtana,
Yes, sir.
how are you? Want to sleep?
No lah.
No lah. I think you know sound already, means sleep already lah. Kirtana Murti. Okay. And this one, who Putang Inamo, this is who? Why the name like that?
Yes.
Who are you? Oh, you. Harry Young, why you change the name like that?
I don't know.
Why Putang Inamo, why like that? Tomorrow want go back school.
No one to
Or
sleep.
Philippine, someone says Philippine words. Is it
Yeah,
Philippine?
it's a bad word. 就是不好的。
Aiyo, you learn all these things, no good. See, someone also know. Jeff told me. No good lah,
没有啦，没有啦，玩罢了啊。
Okay lah. Tomorrow, I don't know whether you can wake up or not. So tonight you must sleep early, no? Too early. Make sure you set your alarm, tomorrow morning cannot wake up. Then first day go to school late already, then gonna punish. Set alarm. After 3 months, I know a bit difficult for you to wake up so early. So what to do? Train no. After 1 day, 2 days, and later on it's okay one. Okay, back to normal. But one thing remember, you must wear a face mask, go to your school. Remember, no, early morning to rush into the car, then never put up the face mask. Then go to school, then no face mask. Remember, no, must bring us the best. If your parents send you, put some face mask inside your parents' car. Okay? No, remember or not? No? No, No, are you there? No, yes. No, never talk one. No, type only. Okay? No. Yeah? Okay, come. Let me ask some question. See whether you also remember one or not. First question I want to ask. Our title is radioactivity, right? Okay, radioactivity. Okay, first question I want to ask. Actually, what do you understand about radioactivity? When you hear these words, radioactivity, what is a thing straight away come out from your mind? Tan Wei Yi, are you there? Tan Wei Yi, Tan Wei Yi not there already. Or Tan Wei Yi also can type. Tan Wei Yi, yes, okay, Tan Wei Yi, what do you understand about radioactivity? Tan Wei Yi, can you type? What do you understand about radioactivity? Tell me anything also can. When you see the word radioactivity means it carry what meaning? Okay, Come, let me see what she typed there. Type yes only. And we just type one thing now. Radioactivity is what? Selena? Selena, are you there? Selena,
Yes.
if I ask you what is the radioactivity, what do you understand about radioactivity?
Wow, 还有这样的啊
Selena, okay. Emission of ionized radiation or particles is Tanwei answer. Emissions of ionizing radiations or particles. I only accept one word only now. Radiation. Yes, correct. Radiation. When she put up the word radiation, memang is carry the meaning of radioactivity lah. Radiation. Okay. Radiation. Correct. Tan Wei Yi, thank you. Okay, I want to test whether you all remember or not. I mentioned it a few times ago. Okay. There are a few types of radiation produced by radioactive, right? Can you name those things? I mentioned a few times already, man. The name of the radiations are what? What are the name? What are the names? I see whether you all can remember what I say or not. Avril Ong? Any idea, Avril?
Alpha, beta, gamma.
I know. Some school they learn already one. I know. Alpha, beta, gamma. Three types lah. Three types of radiation. We are going to learn in detail. Okay. Okay. Next question. Tell me one most important things identified by the Rutherford experiment. Okay, the Rutherford experiment had proven actually three things, you know. So I want you to give me one thing proved by the Rutherford experiment. Xia Xingyi, can you tell me? Xia Xingyi 出来一下咯。Xia Xingyi, Rutherford experiment, right? One most important things proved by the experiment was what? Proved by the Rutherford experiment. Proton. Then someone typed there, no. Proton positive charge. Yes, correct. Harry Young, your answer is correct. It's proof that proton are positive. Xia, what you say just now? Xia Xingyi.
No. No.
Who say? You never say anything. Okay, then I want to hear from Xingxiang, Liao Xingxiang. Liao Xingxiang?
Yeah.
Tell me one thing proved by Rutherford experiment. Liao?
Negative electrons orbits around the nucleus.
Yummy. Rutherford experiment got proof that. The alpha
Positive
particles. Proof what is positive?
charge nucleus.
Yes, correct. Very good. Okay. Rutherford experiment actually proved that the nucleus are positively charged. Positive. Okay. 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 Now we go and answer the questions. Okay. Look at the question now. Answer all the questions now. Okay. Start with question number 1. Yeah. So first, this one very simple. Answer A. Why the answer A? The result of Geiger-Moulton staggering experiment provided evidence for presence of nucleus within the atom. What was scattered? Scattered means all over the places, like scattered in the experiment. Alpha particles. Okay? They use alpha particles. Can you jot it down? Alpha is helium-24. Okay? Positive helium-24. Beta is beta. Beta is electron, -1, 0. Beta actually is a fast-moving electron. Electron is E, -1, 0. Jot it down, huh? Alpha is helium, +1. Beta is negative electron. Gamma is EM. What is EM? Anyone can tell me? For assuming, I know you all study already one because the other day someone asked me this topic question. EM is what? For assuming. Gamma, I put here EM. What is EM?
Sorry, teacher, what?
I see, now the fellow just climb up, you know, he said, teacher, what? I'm asking you. Alpha is helium, beta is electron, gamma, I put there EM. What is EM?
Electromagnetic radiation.
Yes, correct. The first two words correct, but the last word, no radiation. I just say electromagnetic wave is a wave. Gamma is electromagnetic wave. Is a type of wave, you know. Most dangerous one is a wave. Electromagnetic wave. Okay, no chance one, no. Got down, alpha is helium positive, beta electron, gamma electromagnetic wave. So this one is neutral one, no charge one. Most dangerous one, no charge. Okay, question number 2. So what is the answer? In Geiger-Masten experiment, a narrow beams of alpha particles was fired at a thin piece of gold foil in a vacuum. Some particles were scattered through large angle. The result of the experiment provided evidence for what? You notice that some particle deflected to certain angle. So this result prove what? Apple lau. Now I remember Apple lau. I know you asked me many times already. This topic question, I know you send WhatsApp to me to ask one. You were the one, right?
Yeah.
Apple, and now you tell me what answer.
D.
Huh?
D.
Donkey or boy?
Donkey.
Yes, correct. Donkey. Okay. So the answer, donkey, positive charge nucleus lah. Geiger-Masten experiment proved that the nucleus positive. Okay. So these are only things. All right. Number 3. Question number 3. Now, see the question. The diagram shows a narrow beam of alpha fired at a thin piece of gold foil. What is the final direction of most of the alpha particle? Okay, I don't want you to don't need to see the diagram. You tell me now. Most of the alpha particle goes where? Most of the alpha particle goes where? In the experiment?
Go straight.
Yes, go straight. Straight lah. Go straight. So the answer A lor. Go in a straight line. Okay, straight line. Yeah, number 4. Atoms of an element has nucleus surrounded by particles. Which of the following gives a structure? Nucleus having what? Surrounded by what? So which answer is correct then? A not correct now. Nucleus having what inside? Is surrounded by what? So which one is the answer? Chan Wen Kang. Come on, please. Chan Wen Kang. Chan Wen Kang This one also all cannot talk one. C. Chan Wen Kang say answer C. Yes, correct. Okay, answer C. Nucleus is proton plus neutron, then surrounded by electron. This is correct. Chan Wen Kang. Okay, good. Number 5. Which are the following characteristics of neutron? This one very simple. Neutron characteristics is what? Which one? Synphase, characteristics of neutron, A, B, C. Which one answer? A, B not the answer already. So which one is the answer? Synphase? Synphase no sound. Tan Yun Si.
Donkey.
Which answer? Say it again. Yes,
Donkey.
donkey. Correct. Donkey. Same mass as proton. Okay. Neutron has the same mass as proton. Okay. Someone type here. I see what. Synphase say D. Yes, correct. Synphase. Your answer is correct. Synphase. Yeah. Number 6. Answer D. Nuclear number. Remember now, nuclear number is the sum of proton plus neutron. Proton plus neutron. So we call it nuclear number. Okay. Next. How many neutrons and protons does one atom's X, Z, A have in the nucleus? Okay, how? The answer C. Why C? Because number of proton is Z. Okay, Z. So here now. Then here, neutron must be A minus Z lah, because here is neutron plus proton. You get this number, right? Nuclear number. So A minus Z, you get this number lah. Number, no, sorry. A minus Z, you get the number of neutron. Okay, number of neutron. Yeah. Okay, number 8. Lithium got 3 electrons, 3 protons, and 4 neutrons. So the nuclear number is proton 3 plus 4 neutron, 3 plus 4, so 7. Okay, very simple. Right not? Okay, next. Question number 9. Yeah, question number 9. A nucleus represented by X 10, 40, proton number 10, nuclear number 40. How many neutrons and protons? How many neutrons and protons does each nucleus contain? Can you, without looking at the answer, can you tell me how many neutrons, how many protons? How many neutrons, how many protons? Yes, someone said B. Yes, correct. Proton 10 here 10, right? Number of protons. So neutron must be 30, no? 30 plus 10 equal to 40. Okay, correct. Yeah, very simple. Okay, number 10. Which of the following is true for neutral atom? Neutral atom. So which one is correct? Which one is neutral? Jayin, are you still here? Jayin, Tan Jayin, still here lah? Tan Jayin, okay lah. I think I don't want to ask her lah.
Yes, sir.
Yeah, okay. Tan Jayin, can you try answer question 10? Can or not? Neutral atom. Which one is neutral? Yes. The proton, electron must be same one. When proton positive, electron negative same, so they are neutral. Okay, neutral. The rest all not same one, only this one. Okay, 11. Nucleus have equal numbers neutron, proton. This one no. Proton 2, neutron also 2, because 2 plus 2 equal 4. 2 proton, 2 neutron. Then you get 4. So answer B. Very simple. 12. What are isotopes? Isotopes are atoms of same element with different numbers of proton. So remember the name now. Same element, different numbers of proton. Why we say different number of protons? Different number of protons. I think it's not correct. No, I think answer not C. Can you all see properly which one should be the answer? Which one should be the answer?
D. Donkey.
Donkey. Because isotope, their proton number are the same proton number. So the proton must be the same, isn't it? Same proton number, but different nuclear number. When nuclear number different means proton same, then the neutrons different now. So it's D, okay? The answer is D. Not this answer. Same element with different numbers of neutron. Neutron different, but proton same. Yeah. Same proton number, so the proton must be same lah. Okay. Okay, number 13. Which of the following pair isotope is true? Okay, which one is isotope? You see the answer? A, B, C, which one is the isotope? Now, which one is isotope? Right? Kelvin Chi. 13 now, you have the paper. Can you tell me the answer?
C.
Huh?
C.
C. Okay, yes, correct, C. Because proton number same 4, 4. Here nuclear number 6, 8 different. This is isotope. Okay, isotope. Okay, number 14. 3 nucleus X, Y, Z have proton number, nuclear number shown. This one proton number, this one nuclear number. So they ask you which ones are isotope. So the answer A lor. Why the answer is A then? Huh? Why the answer is XY? Why? Okay, let me ask someone. Tai Hoa Khai. Tai Hoa Khai, are you there? Tai Hoa Khai.
Yes,
Tai Hoa Khai. Why the answer is A?
because they have the same proton number.
Yes, correct. You see here, proton number 43, 43, same, right? Same proton number, but different nuclear number. So this one isotope lah, okay, Okay, number 15. Let's study the diagram. This one X, Y, Z, you see, the black one is proton, the circle is neutron, the X is electron, so don't confuse, follow here, So this one 777, this one 666, this one 666. So now the question. Which two are from the same element? So the answer, I already show you, right? Y and Z. So please understand it. Why the answer is Y and Z? They are same elements, or you say Y and Z. Why? They have the same proton number. Now you see this proton number 6, here proton number also 6, so same, right? Same proton number means they are same element, because they have the same proton number. Okay, same proton number. Can I understand? Okay, next. In the parts of 20th century, some scientists investigated the path taken by positive charge alpha into and out of a very thin piece of gold paper. The diagram shows the path of 3 alpha particles. Okay, the diagram is here. I don't want to show you the answer first. I want you to think. You tell me the answer. Okay, this one. Why this one move here? Why this one move like that? Why this one move like that? So they ask you to explain. Okay, 2 minutes. Okay, to explain how to explain this one, how to explain this, and how to explain this. Okay, ready? I already the answer up and I call your name, so you tell me, huh? Okay. Explain why the A like that, why B like that, why C like that. Yeah. Okay, come. Don't worry lah, just try, okay? Also not so difficult lah. Who can Ming? Who can Ming? Are you there? Who can Ming? Who can Ming? Can you explain this? Why move in a straight line and what conclusion is that? Who can Ming? Why the particle move in a straight line and then what is the conclusion?
Most of the alpha particles
Uh-huh.
straight through the void in the origin
Yes,
direction.
pass through straight line. And what conclusion can make?
Most of the space taken up by an atom must be
Yes, they are empty lah. Most of the space of atoms are empty. Okay, correct. So your answer is correct. Can mean. Okay, next one. Let's hear from Yvonne Tew. Yvonne Tew, are you there? Yvonne Tew,
Yes, sir.
Yvonne Tew, please explain P. Why like that? Yvonne?
The alpha particles repelled by the nucleus.
When go near to the nucleus, it got repelled, right? Or deflected lah. How the thing deflected?
Repulsion force produced.
Yes. Why will we repel? Why? Why this thing will be repelled by the nucleus? Why?
Positively.
Yeah, because the nucleus is positive, so the alpha particle also positive, so it will rebel, isn't it? Yes, okay, correct. Yvonne, thank you. Okay, next one. Next one is who? Next one, I want to call this long time never see one. All these people never see them. Ang Xiaohui. Long time never see her already. Ang Xiaohui. Ang Xiaohui, are you there? Ang Xiaohui, can you explain this? Why move like that? Why? Ang Xiaohui? Why the alpha?
Goes bounce back by the go for it.
Yeah. Why this alpha particle will get bounces back? Why will bounce back one? Why will bounce back next?
Exerted large force.
Yes, correct. Because when it hit exactly on the nucleus, right, you will experience a very big repulsion force. Because positive and positive, we have repulsion force, very big one. So we get bounces back now, okay? Okay, now the answer, you look at here, you should write like this. Okay, the answer. So I put it here already. Yeah. Okay, the first answer you say like this lah. Most alpha particles go through in a straight line. So atom has very big empty space. The conclusion is, okay, most alpha particles go through in a straight line. So atom has very big empty space. So the conclusion lah, first answer. Okay. Then the second part, this one, you say alpha go near to the nucleus, deflected with small angle. It shows that nucleus is positive. Okay. Alpha go near the nucleus are deflected with small angle, like this, deflected with small angle. It shows that the nucleus is positive. Okay. And the last one, alpha hit on the nucleus will be bounced back with big angle. So nucleus is positive. Conclusion in nucleus is positive lah. Okay. So got all the answer now. Okay, jot down all the answer. Go straight, be rebel, C bounce back. Can but we need to explain also lah, Okay. Ready?
Okay.
This one your answer is correct, but you need to add a little bit of explanation and a conclusion lah. Yeah, finish everyone. Okay, finish here now. Okay, come now. We come back here. Okay, last few minutes lah. Can you all try to on your camera, everyone? Because I think for a few months already, I never see your face, you know. Can you on your camera? If you can on your camera, just for one minute also doesn't matter. Can on camera? On camera can or not? Can Ming on your camera lah, Can Ming? All very quiet already, no. Nobody on camera. For Su Ming, can you on your camera? All very quiet. Jong Han, yes, good. Jong Han. Long time never see you, Jong Han, Yu Kai Chi, okay, good. Yu Kai Chi cut your hair already, Che, ready to go back to school,
Yeah.
Ken Ming, okay, good. Nicholas, all very handsome, all hair cut hair already, Harry Young, come, let me see your face, Harry Young. Come on,
Cannot. Nah.
Also cut hair already, go back to school, everyone. Hoa Khai, can on camera or not, Tai Hoa Khai?
No.
Cannot lah, okay lah. Now my I don't want to force you all I know. Especially girl, you're very shy one, very shy. You want to on camera one. Okay, now my okay lah. I think tonight I want to stop here lah, so that you can go to sleep early, everyone. Sleep early, have a good rest. Set your alarm tomorrow morning. Wake up early, go to school, Okay. All right? Can or not? Okay lah. I see you next lesson lah, So enjoy your school day tomorrow, So rest early tonight. Sleep, After this, go sleep already, Then tomorrow morning wake up early. Okay? Okay lah. I think that's all lah. Bye-bye, everyone. Bye-bye.
Thank you, sir.
Bye-bye.
Thank you, sir.
Yes, bye-bye. Bye-bye. Okay, bye-bye,
Thank you, sir.
Yes, bye-bye. Okay.
Thank you,
Bye.
sir.
Yes, bye-bye. Bye-bye.
Bye-bye, sir.
Okay, bye-bye.
Thank you, sir.
Yes, bye-bye. Bye-bye,
sir。
Yes. Why?
那个嘛，不是我们有分两班 class 啊，我们的那个地方在哪里？我们老师没有跟我们讲哎。
Science 3是在 library 的上。
有 A 跟 B 吗？
靠近的地方呢，都是在 library 那个 block。
OK，A 跟 B 都在那边
你明天早上你在省流区排队了，对吗？然后在写 temperature 的时候，那个老师会告诉你去哪里的。
OK。
有老师会告诉你们去哪里的。你的是在 library 那边
，OK。
Yeah, okay, bye bye.
Bye bye.
Bye bye.
Say it again.